Okay, good morning. Welcome to
KidMath number 99.
KidMath number 99. I have to go over to work early today, which is too bad. So we're just going to talk about the next section without really talking about it.
Okay.
Make sense?
Yeah.
Okay, so the next section is about adding functions. Okay, doesn't seem like that should be too hard to do, right? But I wanted to start with a tricky example. Okay, so we're going to let f of x equal the square root of x, and g of x equal the square root of x minus 4. All right?
Right.
So what is the domain of each one of these? Okay, how about let's start with square root of x. What's the domain of square root of x?
Well, assuming we want the range, should we keep the range real?
Yeah, yes, we need to keep the range real.
Okay, so any positive number could work.
Yeah, any positive number could work.
Negatives, you're gonna get i's.
Yep.
0, you get square root of 0, which is undefined.
What?
You get square root of 0, which is 0.
Which one is it? Is it undefined or is it 0?
It's 0.
It's 0. Okay, so what's the domain?
0. It's all numbers greater than or equal to 0.
Okay, so the domain of this one is all x greater than or equal to 0. Okay, awesome. What about this one?
Well, x has to be bigger than or equal to 4.
Okay, all x bigger than or equal to 4.
Because if you get 3, then you're going to get negative square roots. Which isn't pleasant.
Not pleasant.
Right.
But 4 works, right?
Yeah.
Because the square root of 0 is?
0.
Yeah. Okay, now, can we add these functions? So, could we write down a function that is equal to, I guess, h of x, we'd call it? F of x, g of x, h of x. The square root of x plus the square root of x minus 4. Do you think we can write down a function like that?
Well, is this a function?
Interesting. Is it a function?
Well, so we need for every input there to be one output.
Yep. Every input in the domain needs to have an output.
So let's say, maybe we should find the domain of this.
Okay. Good idea.
So this one can be any real number bigger than or equal to 0.
Okay, so this is x greater than or equal to 0.
This one's x greater than or equal to 4. So any numbers greater than or equal to 4 work for this.
Ah, very good. Okay. 0 doesn't work for the sum, right?
Yeah.
1 doesn't work for the sum. Okay. So for this, we have to have all x greater than or equal to 4. So basically, this domain
is the domain of the whole thing.
Which was more restrictive than this domain, because this domain, every number in here is in here.
Yeah.
But the reverse is not true. There are some numbers that this works for that this doesn't. So when you add together, you have to be very careful about the domains, and that's really important.
Yeah.
Okay, that's really important. Tomorrow, I'm going to show you, or maybe not tomorrow, but soon I'm going to show you a question that was on a test for high school kids that the people who wrote the test got wrong. And we're going to talk about this. But here's an even kookier example. Suppose I won't use f and g, I'll call a of x equal x plus 1 over x, and b of x equal x minus 1 over x. Okay? What's the domains here?
Well, 0 doesn't work for any of them.
Right. Oh, but all other ones work, right?
Yeah.
Okay. And if I let c of x equal a of x plus b of x, which equals what?
Well, it's x plus 1 over x plus, it's 2x.
That's 2x. Now, what's the domain here?
Well, 0 still works. 0 works.
Okay.
Actually, any number works.
Looks like any number works. But because this is coming from two functions, adding two functions where 0 didn't work, 0 is not going to be in here. Okay? So this is all real numbers not equal to 0, all real numbers not equal to 0. So this function, because I've defined it as a sum of these two functions, even though it looks like 0 is going to work, 0 can work.
Interesting.
So I just wanted to talk about this just to show you that sums and products and things like that with functions, tiny little bit more tricky, just because you have to pay attention to the domains. Okay?
All right.
All right. Good job, sweetie pie. Good job.